Hey there, geographers. It's Angela here with another video lecture in physical geography. And this week, we're going to continue talking about the lithosphere, especially as it pertains to weathering, erosion, and mass wasting. So, once we have this amazing new land that is created and comes to the surface of the earth, well, what happens to it? So, once this earth comes to the surface of the earth, it is exposed. It's exposed to our air and it's exposed to water and to different types of weather. So, these rocks are going to disintegrate or decompose because they are on or they're near the earth's surface. So, if you can imagine rock that is below the earth's surface, it's going to deteriorate and change in a different way than if it were above the earth's surface. So the questions that we ask ourselves are, how much of the rock is exposed? What are the existing conditions? Is it humid? Is it cold? Is it hot? Is it like the high desert? Does it go from cold to hot to hot to cold? And how much water is there? Is this a place with lots of water? Is it a place with frozen water, with snow? Is it a place with a lot of warm, hot rain? Are there lots of microscopic organisms that grow on the rocks? So we have to ask ourselves a lot of questions. Now, there are two different words that we need to use in terms of our vocabulary for this chapter. The two first words that we're going to use are endogenic and exogenic. Now, think of the prefixes end or endo, and then think of the prefix exo. Whenever we talk about something that has a prefix exo or ex, it means exterior or out. After all, think of the word exit. The word exit means to go out. How about an exoskeleton? An exoskeleton is a skeletal system for an organism that is actually outside of its body. So exo means out, endo means in. Think of like an endoscopy. It's a procedure that you have done so that doctors can see what the inside of your body is functioning like. So these two words remind us that there are forces going on within the Earth's surface and forces, exogenic, that are going on outside the Earth's surface. So these two words are really important. Endo meaning inside and exo meaning outside. This also pertains to bedrock. So for example, if we're talking about a volcano or volcanic activity, this is going to be igneous rock. And this igneous rock is going to behave underneath the Earth's surface as bedrock and eventually disintegrate to where it is above the Earth's surface. Definitely as bedrock, it's near the Earth's surface. So over time, all the processes that physically disrupt or chemically decompose a rock at or near the Earth's surface is called weathering. Here are three different ways in which bedrock on or near the Earth's surface can what we call weather or decompose. In terms of bedrock, bedrock can disintegrate in one of two ways, either in a joint block fashion or in a granular fashion, as you will notice here in these two diagrams. Some of the most famous examples we have on planet Earth of joint block disintegration are Giant's Causeway in Northern Ireland. As you've noticed here, it looks like someone actually chiseled this rock into the shape it has now become. And what I must tell you is that, surprisingly so, this rock is actually disintegrated into this shape totally, completely on its own. This is natural. This is not human or man-made. Weathering also occurs in what we're looking at here through joints and pores. So these joints are a passageway that weather agents enter. So over time, these rocks disintegrate and open up various joints that either plants, organic material, weather, or frozen water can go ahead and enter and then continue to alter the landscape. For example, What we're looking at here that I'm circling right now is a very famous landscape called the Burn in Ireland. Down here, we're looking at an idea of this is actually out in the Mojave Desert. This is Joshua Tree, famous for its rock climbing. Also, throughout the day and throughout the winter, this is high desert, gets very, very cold at night, and then has the ability to get very warm during the day. So these rocks undergo expansion and contraction on a daily basis and are eroded as such. Rocks undergo two different kinds of weathering. Physical weathering is the first one that we're going to learn about. It's a breakup of massive rock, bedrock, by physical forces. One of those physical forces is the climate and water. Water expands as it freezes. So we have something that we call frost action. So it's called frost cracking. And when water expands as it freezes, it fractures the rocks. And this is a dominant process in high Arctic and high mountain environments. Additionally, another kind of physical weathering that we have, especially in the southwestern United States, is salt crystal growth. This is famous in Mesa Verde and places like Zion National Park, Grand Canyon as well, where water actually seeps and infiltrates in through sedimentary rock that's permeable, which means that water is able to flow through that surface. And then when the water comes into contact with the type of rock that it cannot flow through, that's impermeable, which means the water cannot flow through that surface, the water must exit and create these areas that water actually exits. Because of evaporation, massive evaporation in the Southwest, which is a desert environment, you will notice that salt is not able to be evaporated. Since there's a lot of salt in the water, especially in the desert, the water will be evaporated, and since the salt is not able to be evaporated, the salt remains and creates these little niches. This is another example of physical weathering. You will notice this sort of physical weathering in Weeping Rock in Zion National Park. Water is always dripping from this rock. It's an example of groundwater flow and creation of salt crystal growth, and it's always eroding away this part of the rock. Another example we have of physical weathering is called exfoliation. Rock is exposed at the surface and it releases pressure. So, for example, this igneous rock that we see here in Yosemite Valley actually used to be condensed and surrounded by igneous rock of its own kind. And the minute that it became exposed, that rock wasn't surrounded by other rock. It was exposed and therefore expanded and starts to exfoliate or shear off. One of our greatest examples of shearing an igneous rock is Half Dome in Yosemite. Other ways in which our urban environment can erode as well is just by simply looking at some of our urban landscape sidewalks. The second type of way that rock can be eroded is called chemical weathering. Chemical weathering is different to physical weathering in the sense that a compound is actually going inside the rock and changing the rock's actual chemical makeup. It's changing the minerals. So this is not a physical change that's happening. It's something that's actually going inside the actual rock and altering its absolute chemical makeup. So the decomposition or decay of minerals in a rock by chemical reactions with water, oxygen, and acids, and this is going to be most effective in warm and moist climates. After all, when you're ever in a chemistry class and you want to speed up a reaction, you're going to heat it up. Types of chemical weathering include hydrolysis, oxidation, which includes oxygen, and carbonation, which requires carbon. So reactions turn these existing minerals into new minerals, and then they change. So, for example, chemical weathering includes a process called oxidation. Oxygen and water react with metallic elements in minerals, making the minerals unstable and therefore causing the rock to degrade. So, for example, you can take a look at some of these headstones, both of them made out of different kinds of rock, both under the element of chemical weathering. A second type of chemical weathering we have is called carbonation. It includes a carbonic acid and it dissolves limes and it weathers things. Yep. Let me go ahead and scoot this down. So carbonation weathers buildings and tombstones, and it dissolves limestone and creates caverns. And we're going to go ahead and take a look at that right now. So we continue our conversation on chemical weathering. There is a type of rock that's called limestone. Limestone forms the basis of bedrock for many places in the United States. Different parts, like, for example, caverns down in New Mexico, and also almost the entire state of Florida. What happens is that places, like I've said before, that are warm and involve a lot of water, the water actually combines with carbon to create a carbonic acid, soaks and infiltrates into the bedrock, and slowly chemically alters the minerals within limestone and changes the rock altogether, and it starts to eat away at it. This is chemical weathering. So let's take the state of Florida for example. Its main bedrock is limestone, and as a result, they experience sinkholes where it looks like the top surface of the earth is completely fine. But what happens is that since most of our fresh water in the entire earth is held underground and not on the surface, this water has the opportunity to sit and, when combined with acids, slowly chemically alters limestone and it eats away at it and dissolves it. So that way, many people in Florida don't realize it, but they're actually living over a sinkhole because over time, that water and that carbonic acid slowly dissolves away the land that's underneath them. So, this map here shows you the dots of reported sinkholes in Florida since 1954. This map on the left-hand side says, how vulnerable are you to sinkholes? Now, if you decide to move to Florida, this is a map that I'm pretty sure you'd going to want to look at. After all, people do lose their lives and their homes to these sinkholes, and this is an example of a home in Florida with a sinkhole, and the resident died. So, as a result, what they do in places like Florida is there are companies that come out and they will come in and with cement, they will fill in the places of the bedrock that are slowly being eaten away. They'll fill in everything with cement.